Purdue University, home of the Boilermakers, began powering and heating its campus in the late 1860s. The present power plant, built in the early 1960s, supplies steam to heat about 13 million square feet of campus, along with chilled water to cool about 7 million square feet. The plant also supplies about 60% of Purdue's electric power, with capacity to power the entire campus. But maintaining and upgrading the plant's process system was difficult.
Well, really, before we started the DeltaV project, we were running a bunch of different control systems, several different PLC systems. We had a lot of older control systems in the plant. The main control system that we were running, it was a little cumbersome. Downloads were difficult to do. Old control systems are very proprietary. And that's one thing we were trying to get away from. And that's one of the reasons we picked DeltaV. It's a Windows-based system. It runs on a standard PC. It's Windows NT-based. It's point and click.
Purdue found an ideal place to try out the DeltaV system.
The first step really was boiler 3. We really addressed the initial concerns by picking the right piece of equipment. The piece of equipment that we picked was a boiler that isn't run a lot. We still controlled all the valves pneumatically. Little twist dials, everything was air controlled, and we felt boiler 3 would be a good spot to try out a new system before we jumped into it. We had very little problems. The reliability was great. We hadn't lost a module, hadn't really seen any communication errors, which was typical of our old system.
Based on the success of this initial step, Purdue then integrated DeltaV with the old control system.
The first project put a lot of our fears at ease. The second project that we did was the South Tower, and at the time we really weren't concerned with the control system. We were actually doing the cutover live. The units were running while we were cutting them over, so it was really a matter of timing then. And there again, the operators were already familiar with the graphics, so training them how to run them was pretty easy.
We had at the South Cooling Towers, we had an existing system, and we were planning a 2-week shutdown to change over to the new DeltaV. Well, at the last minute, this got changed, and we had to go to keeping the existing system running and switch over to DeltaV one cell at a time. And so we had to temporarily hang the DeltaV while we changed over one system at a time, or one cell at a time. Other than, of course, the nightmare of having to keep the two systems running while we're online, because if you knock South Tower down, you knock the whole plant down. We had very few problems. In fact, the management was very happy that we were able to do this and not knock them down in any way. No loss of any pumps, fans, and it's all critical equipment for the powerhouse.
DeltaV provided a smooth integration path.
We knew all their function codes and how they worked, and we could mirror that into DeltaV. So DeltaV became a window for us into our old system. Really what the window gave us is it gave us the opportunity to give the operators a new window to the old process. What they were able to do is they could control everything through the old system using their new window. They had the look and feel of DeltaV, but actually down at the point level we were still using the old system. And from a troubleshooting standpoint, we were still getting all the module information and the error information from our old system across into DeltaV.
At that point in the conversion, Purdue had no reason to stop.
We had in our budget enough money to replace the old control system. We could cover the cost to convert everything over to DeltaV, so that's what we started doing.
With each success, Purdue took advantage of different methods to transition its existing system to DeltaV based on what made the most economic and operational sense to the plant.
As a matter of fact, Boiler 5 right now is still running on the old control system. We changed nothing in the field. We didn't have to rewire anything. All we did is add a serial interface that went from the old control system into the DeltaV. Since February of this year, we've cut over 3 chillers. Chiller 6, 7, and 8. We've ripped out the old system and put in DeltaV. We've brought several new systems up on DeltaV. We've put in a chilled water expansion system. We put in several boiler feed water pumps. We've brought 2 new chillers, electric chillers in. The control system is actually another model, but there again we interface it into DeltaV. We found very few instances where we can't bring another language into DeltaV. And the whole idea is to keep everything consistent for the operators.
Beyond easy incremental transition, Purdue saw operational and engineering benefits.
Yes, it's been very easy to work with the DeltaV system. It's really been helpful. The things that I realized about it real quick, most of the things we're doing here is we're retrofitting into existing cabinets when we take the old control system out. The size, compactness of it allows us to add terminal blocks to make sure that the field wiring is going to reach.
The networking has been really easy to implement. We run a primary and a secondary main hub in the control room. We run 2 sets of consoles.
In the south tower, we had a fiber optic from there back to the main plant. It was very nice. It's one of the things that I like about this system is it's very easy to network in another workstation or another cabinet.
Other advantages, really the biggest advantage is it's easy to configure. You can add a new module online and do a download without affecting the process. The online editing features that it gives you, they're easy to use. Now we can change whole control philosophies without shutting down the unit. The online documentation is great. You don't have to keep hard copies anymore. You just have to keep backups. And from the online documentation, not only is it a documentation tool, but it's a troubleshooting tool. Plus with Pi online with DeltaV, you're able to go back and track information a little easier than we could on the old system. In the old system we were using, you'd pretty much have to build a trend and let it run and watch it while it was happening. And with DeltaV and the embedded history that it has, you're able to go back in time and check it out without having prior knowledge of there going to be a problem.
The trending kicks butt. It does. My ash system, I'm not stripping more than I need to, right? I can be a lot more efficient. I'm not wearing out those pumps and stuff like that because I can look for the last 24 hours, last week, last month, and see how often we're doing that, right? That's a big plus. And then it really helps us control the tower that we use for our chillers and for our generator. Helps us control the chemicals in that tower. We can see exactly how often we're blowing that tower down. We can trend the TDS, total dissolved solids, in that tower, and we can tighten up a lot of our systems that way. I look at the trends every hour on the hour.
As far as troubleshooting transmitters, DeltaV and the little blue bar below the detail is one of the best things I've ever seen, from the standpoint that if I get called in for a control problem, and control guys everywhere I think will tell you, boy, they see a lot of software problems that aren't software. If you've got that little blue bar below the detail, it's not a software problem. You're getting a bad reading in from the field. And many times, I mean, we can look at that and tell you, hey, you got a blown fuse, or the transmitter's under range or over range, or there's something wrong in the field. It's not in the software.
Because of the benefits realized, Purdue can turn over more control more quickly to DeltaV.
Since February, we've done 3 switchovers and 3 new installations. We can do a switchover, and by switchover I'm talking 100, 150 point system. We can do that in a week and a half, 2 weeks. And that's, jerking out the old control system, putting in and wiring the new one, loading in the graphics, loading in the software, and starting up.
For Purdue, the future pathway is now very clearly laid out.
We are getting ready to try our hand at field bus. Again, opportunity is the key. With the boiler that we're getting ready to convert over, there are 16 temperature inputs that are monitoring only. They're not used for control, they're not used for shutdown. And that's a good place for us to try that out. We're going to a total DeltaV system. In the next 2 years, we will have converted over everything on the old system to the new DeltaV. Anything new that we're bringing in is coming up on DeltaV. And like I said, one of the greatest advantages that we've found to the system is it can talk any language through the serial interface. We bring all of our PLCs into the DeltaV.
Rapidly scaling up on DeltaV to plant-wide control of Purdue's boiler plant means an eventual 5,000 I/O.
At the time we put it in 2 years ago, the point count was 200 points. And now we're well up above 20,000, I believe, is what the system's capable of now, which is more than we'd ever use in our existing plant, which really shows us we picked the right system. It's grown to fit our needs, and now it's really surpassed our needs.